Hey everyone, and welcome. Today, we're going to tackle one of the most powerful and, let's be honest, often confusing concepts in C, the relationship between pointers and arrays. Stick with me, because by the end of this, I'm going to show you a secret that will completely change how you look at C code forever. So if you're learning C, does this feel familiar? Pointers seem like this abstract nightmare, the source of all your bugs. But arrays? Arrays feel simple, straightforward, easy. It's a feeling a ton of developers have had. But what if I told you that clear line between them is basically an illusion? What if, under the hood, they operate in a way that's, well, almost identical? To really get how this works, let's start with a really simple analogy. Okay, I want you to imagine a street. And on this street, you've got houses lined up right next to each other, one after the other. This little mental picture, it's the key to understanding how memory works in C. So, in this analogy, the entire street of houses, that's our array. Each house is an element, all sitting there in a nice, neat row in memory. The name of the street, let's call it Main Street, is just like the name of our array, RR. And just like one Main Street is the address for that first house, the array's name itself is basically the address of its very first element.
So where do pointers fit into all this? Well, a pointer is like a sticky note, and on this note, you haven't written a description of the house. You've just written down its exact address, like one Main Street. That's all a pointer is, a variable that doesn't hold a value, it just holds the location of a value.
All right, got that analogy in your head? Good, because we are ready for the big reveal. This is the fundamental truth that connects everything we've been talking about. And trust me, once you see this, you can't unsee it. And here it is. This is the secret. Whenever you write R at I, you're just using a nice, convenient shortcut. It's what we call syntactic sugar. But what the C compiler actually sees, what it actually executes, is R plus I. Let that sink in for a second. Array indexing is just a friendly disguise for pointer arithmetic. Now, here's the more technical way of putting it. When you use an array's name in your code, just R by itself, C automatically converts it, or lets it decay, as they say, into a pointer to the first element of that array. Now, they aren't exactly the same thing all the time, but for most of what you'll do, they behave identically. So if R of I is really R plus I, then that little plus I part is incredibly important. This is pointer arithmetic, and understanding it is like unlocking a new superpower in C. It gives you this direct, incredibly efficient control over memory. Okay. But here's the number one trap people fall into. When you add 1 to a pointer, you are not just adding one single byte to its memory address. That is absolutely not how it works. So here's what really happens. Pointer arithmetic is smart. It's automatically scaled by the size of the data type it's pointing to. So if an integer takes up 4 bytes of memory and you add 1 to an integer pointer, you're telling the compiler, hey, move forward by the size of one whole integer. It adds 4 to the address, not 1, landing you perfectly at the start of the next element. It's brilliant. Theory is great and all, but let's actually see this power in action. We're going to take what we've learned and just apply it to some simple code to make it absolutely crystal clear. Okay, imagine we have an integer array, and it's got the values 10, 20, and 30. If we make a pointer, let's call it p, and point it to the very beginning of the array, star p gives us the value at that address. What is it? 10. The exact same as r of 0. Now what about star p plus 1? That moves us to the next integer's address and gets us its value, 20. The same as r of 1. You see the pattern here? It's the exact same logic, just written differently. All right, pop quiz time. Let's see if you've really got this. Take a look at this code. We're trying to print to array. I mean, that just looks wrong, right? It probably shouldn't even compile. But it does. So what do you think it's going to print? The answer is 7. I know it's wild, but here's the beautiful reason why. The compiler sees to array, and because of the rule we just learned, it translates it to star of 2 plus array. And since addition doesn't care about order, it's commutative, that's the exact same thing as star of array plus 2, which is just the long way of writing array of 2. It's the ultimate proof that the secret works both ways. Now, as they say, with great power comes great responsibility. This direct access to memory is what makes C so incredibly fast, but it's also where some really nasty bugs can hide. So let's go over the most common traps you absolutely need to avoid. First up, out-of-bounds access. C is not going to hold your hand. It will happily let you read or write memory way past the end of your array, which can lead to corrupted data and spectacular crashes. Second, using the wrong pointer type. If you try to read a 4-byte integer using a 1-byte character pointer, you're going to get garbage. And finally, dangling pointers. Never, ever use a pointer after the memory it's pointing to has been freed or deallocated. The key is you have to be mindful of your boundaries.
Phew, we have covered a ton of ground. So let's just quickly boil it all down to the most important takeaways.
Just remember these 4 things. 1. An array name usually just acts like a pointer to its own beginning. 2. Those square brackets are just a nice-looking shortcut for pointer math. 3. Pointer math is smart. It moves in steps of the data type, not single bytes. And 4. Understanding all this is the key to unlocking that raw speed and control that C is so famous for.
So there you have it. The secret is out. That wall you thought existed between arrays and pointers, it's really more of a thin veil. Now that you understand this deep connection, you have the power to write cleaner, faster, and much more effective C code. So the only question left is, how are you going to use it? Thanks for joining me.